In this video, I want to have a look at right-angled trigonometry. So we'll start off having a look at this right-angled triangle. So this side here, it's the longest side of the triangle and it's opposite our right angle. That side is always going to be called our hypotenuse, or HYP for short. What we call the other two sides depends on which angle we're looking at. So if we were looking at this angle down here, then the side next to it would be called the adjacent side, or ADJ for short, and the side over here would be called the opposite side. If we were instead looking at this angle up here, then these two would switch around. So now the one next to it here is the adjacent, and this one directly opposite it is called the opposite. Alright, so whichever angle we're looking at, we can now figure out the relationship between the sides in a triangle using our three trig ratios. So we've got sine, or spelled S-I-N for short. So sine of our angle is always equal to the opposite side over the hypotenuse. Cosine, or cos, of our angle is equal to the adjacent side over the hypotenuse. And the last one is tangent, or tan, of our angle is equal to the opposite side over the adjacent. For short, to remember that, you can remember SOHCAHTOA. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. The other thing you need to remember about right-angled trigonometry is what's called angles of elevation and depression. So if we have a look at our little picture down here, we've got a car and a building. If there's somebody standing at this car looking up to the top of the building, then that angle that they're looking up is called the angle of elevation. On the other hand, if there's somebody standing on the top of the building and they're looking down towards the car, the angle that they have to look down is called the angle of depression. So to measure that, we'd have to draw in a horizontal across there. It's not very horizontal, my horizontal. Okay, so that's our angle in there, and that would be our angle of depression. So the angle of depression is if you're up the top looking down, so it's that angle in there. Angle of elevation is when you're at the bottom looking up. Okay, so let's have a look at using our trig ratios to solve problems. So in this first one, we've got a right angled triangle. It has an angle of 50 degrees, a side length of 20, and we're trying to find this other side here. So the first thing we need to have a look at is from this angle, our 20 meters is the adjacent side, and our x is the opposite side. So the ratio that involves the opposite and the adjacent is tan. So we know that tan theta is equal to the opposite over adjacent. So then we can fill in the information that we know. So we've got tan of 50 degrees is the opposite, which was our x, over the adjacent, which is 20. So now we've got an equation and we need to solve that for x. So to get rid of this divided by 20, we're going to multiply both sides by 20. So we'll have 20 times tan 50 is equal to x. Now if we put this left-hand side, this bit here, into your calculator, you'll figure out what x is. And if we round it to one decimal place, we'd come out with 23.8. So that side there is 23.8 meters long. In our second example, we've got an angle of 60 degrees, a side of 100, and we're trying to find the hypotenuse in this case. So we start the same way. From that angle, this 100 meters is our adjacent side, and that x is the hypotenuse. So the trig ratio that involves the adjacent and the hypotenuse is cos. So we'll write cos theta is the adjacent over the hypotenuse, then fill in what we know. So cos of 60 degrees is equal to 100 over x. Now the difference between this equation and our first example is that in this one, our variable, our x, what we're trying to find, is in the denominator. So we need to get that out of there, so let's multiply both sides by x. So we'd have x times cos 60 is equal to 100. And now we'll need to divide by that cos 60 degrees. So we'll have x is equal to 100 divided by cos 60. Then you can pop that in your calculator, and if you put that in, you'll end up with exactly, not even approximately, you'll end up with exactly 200. So that hypotenuse is 200 meters long. In our last example, the question says, a boat is 120 meters from the bottom of an 80-meter tall cliff. Calculate the angle of elevation from the boat to the top of the cliff. So whenever you get a worded question, the first thing you always need to do is draw a picture. So let's draw, we've got our cliff coming down here, this is the ocean, and our boat is over here. Nice little diagram. So that boat is 120 meters from the base of the cliff, and the cliff is 80 meters tall. Oops, sorry, 80 meters tall. Right, so now we need to draw in our right angled triangle. So that's our right angle there. From the top of the top of the cliff to the boat, that's where we're going to draw in our right angle there. Sorry, our hypotenuse. And what the questions ask us to find is the angle of elevation. So that's going to be this angle in here. So we need to figure out which sides we've got. So from this angle, our 80 meters is our opposite side, and our 120 meters is our adjacent. So opposite and adjacent, again, is tan. So we know that tan of theta is equal to the opposite over the adjacent. So in this case, that's going to be tan of theta, because that's the angle that we're trying to find, is our 80 over 120. So in all of our other questions, we've been trying to find a side length. In this one, we're finding an angle. So if we're trying to get this angle on its own, we need to do the opposite of tan, so what's called tan inverse. So on your calculator, there's a button above the tan that looks like this, a tan with a little -1 above it. So that's tan inverse, and we want to do tan inverse of 80 over 120. So you need that fraction in brackets. So depending on which calculator you have, you'll either have to press shift tan or second function tan to get this bit. If you put that in your calculator, then you need to press your degrees, minutes, seconds button, and you should end up with 33 degrees and 41 minutes to the nearest minute. Okay, so that's a few examples of right-angled trigonometry.